I have never really gotten to the chapter workout before. We both got like. Three essays. Or no, I like mine is like going to front. Like I finished my last joke and there was like I went up the stairs and I just and like went back to my water bottle.
Okay,
I think it's just around.
if you guys can put at the top, I've got to put this at the top of your packet. So this is the final packet that I'll be handing out to you guys. Packet 4 and packet 4 packet number 4 keys. So make sure that it'll be easy for you to distinguish between different packets. I've got to put number 4 at the top. Okay. So this will be worth basically worth a 50-point test grade because the other 50 points is coming from the test that we're going to take Monday and Thursday, next Monday and next Thursday, because they're shorter periods. So I just want to quickly go over the calendar of what's coming up. So we're going to be working through first semester topics today through Friday, but I'm not going to make this packet due until next Friday because next week is kind of crazy with all the shortened days. So this packet is not due until next Friday, but I'm sorry, my bad. I'm still going to check pages 1 through 4 tomorrow and pages 5 through 8 on Friday. But then after that, pages 9 through the rest of the packet, I'm not going to check until next Friday because I don't want to. I already have such limited amount of time in each day, so I want to use those days to do as much review as I can. So after page 8, the rest of the packet is due next Friday. Okay, so today through Friday. We'll work on first semester topics, which is included on pages 1 through 8. And then if we can, it would be good for us to start looking at some second semester topics, even though it's not showing up till next Thursday. So next Monday, we'll take a multiple choice test just over first semester topics. And it'll be 8 multiple choice questions. Okay. You have 30 minutes. To do those 8 multiple choice questions. Now, I just want to tell you, okay, a couple of things. First, you'll get to use your calculator. Second, no formula sheet, but I'm going to ask you guys, I'll highlight exactly what I want you guys to focus on in terms of memorizing, and it's on that final page with that formula sheet. So you're just responsible for first semester formulas. And that's what you're working towards on Monday. I'm going to be grading your multiple choice like as if it was free response. Okay, you guys are still get to look at the multiple choice question, answer a question. But I'm going to grade it like a free response. What that means is they can get partial credit even if you get the problem wrong. But that also means that if you just circle the answer and there's work that I want to see and you're not showing me that work, you'll only get partial credit there as well. Okay. So that's not the way that AP exam is going to grade, but right now I want to see your process. I want to see what you know. So that's why I'm grading it that way. Now, having said that, I know there are some problems that you really can't do much work because it's just a graph. And if that's the case, then I will adjust accordingly. All right. So if something can be done without much work, then I'm not going to be requiring work. But if a problem requires multiple steps to get to the answer, then I want to see those steps. Okay. And if I mark something wrong and you feel like you should earn credit because you understood that topic, that problem, you can come to me and we can discuss. And if you show me that you understand that you did it all in your head, then I'll gladly give that points back to you. I just want to know that you understand the answer or the process. Okay. Okay. So Tuesday and Wednesday. I think Tuesday may be a shorter day, maybe like 20-minute class. I think we're back to 30-minute class here. So I'm shorter class, 20 minutes, 30 minutes. So we'll spend these days to do more review, and then Thursday you guys will take the multiple choice test over second semester topics. Okay. I'll try to have I'll have morning review Monday. I will try to have morning review on Thursday. I'll let you know. I have to proctor the bio, EOC, so I don't know exactly how the time frame's gonna work. But if not, if I can't do it Thursday morning, then, I may do a Wednesday, morning help session for the Thursday. But either way, I'll give you a morning help session. It just may not be on that Thursday because of, what I may need to do with, prepping for that EOC. Okay, so, this will be worth a 100-point test grade. You got 25 points, and then packet 4 is 50 points. Okay. Any questions with that? Okay, and then after this week, or after next week, this will be the first week of AP exams. I'm going to be spending each day going over FRQs. I can't do all the FRQs in the packet, but I can maybe do like 2 or 3 each day, and the rest you guys try do for homework, and this is due at the end of the school year. And also your packet number 6, I'll be having morning and afternoon help sessions to go over that multiple choice packet number 6. Okay. I do want to make sure that you understand, you are aware of all the resources on my website. So once you go to my website, and once you go to the May portion of 2023, you're going to see all the FRQs. That's from packet 5. And I have all the videos for them. I think the only thing I haven't done videos for is 2022. So I'm going to try to get those in case you want to. But I'll still do this in class. It's just, these are videos I recorded from previous year. If you want to, you guys have the key, but if you want to have the video resources there. And then from packet 6, if you go to further down, I put this under Saturday, May 6th. I have all the videos for the entire packet. And you guys have the key already, but I want to make sure you knew where the videos were. If you're stuck on a problem and you want to see me walk through that problem, you click on that video. But I'll also do this packet during my morning and afternoon help sessions that first week of May. And then that Sunday, right before your AP exam, I'll have a help session over Teams, last minute questions and last minute things I want to go over with you. Okay. So you guys may not feel it, but to me, it feels like that at least we're at a point where we're kind of over the hump. And what I mean by that is these are the major topics that can show up on FRQ questions. Okay, and I want to show you how much of it we've already done. I mean, we've hit all the big things. I know area involving we haven't seen in a while, but we can go back and review. We've done FRQs as we prepare for our tests, but I haven't really focused on area and volume since that's the most recent topic. Charts with Riemann sums, mean value theorem, average race values. We've seen that from the previous FRQ quiz. Derivative graph, we know how to do that. Slope fields with different equations. You guys just saw that on the quiz yesterday. Related rates, we saw portions of it as we reviewed. Accumulation functions, these are rate in, rate out, antiderivative word problems, we've seen that. Implicit differentiation, usually these are not full FRQs, but we've done implicit differentiation as we did review. Particle motion, we've done charts of F prime, F double prime. We have problems with a table of values. Function miscellaneous, we saw that on the first FRQ quiz. So I think we're at a point where if you look at an FRQ, you're not completely lost because we've seen portions of it. You still will probably need to look at the key intermittently as you guys are working through your FRQ packet. But the reason why I want to focus on this is because this is what I think scares students the most. But I feel like getting to the point where we're seeing all the things that could occur and then kind of strengthen as you guys work through your 2016-2022 FRQ packet. I think that will really make you feel a lot more comfortable heading into review. And then also, as we're reviewing these topics, we're also preparing for multiple choice as well. It's just that I'm saving multiple choice until now because I feel like as we go through, we're gonna already know how to do a lot of it. There are some pockets of topics that don't show up on FRQs, but we've hit all the major things that we could see in multiple choice as well. So that's why I just decided to wait until later to do multiple choice, because as we did FRQs, we're also kind of reviewing for multiple choice. Okay, so I do encourage you guys to make progress with your FRQ packet number 5. If you are not able to finish both packet 5 and 6 before AP exam, then that's and if you have to choose between two of them, I'd rather you try to finish your FRQ packet, because that feels like the more significant portion. It's good to do both, but if you do FRQs, you're also preparing for the multiple choice. Okay, so all right, let's look at packet 4. All right, I highlighted in orange the topics that are fall semester. Okay, so let me just go through these. Limits and continuity and L'Hopital's rule, product, quotient, chain rule, implicit differentiation, theorems such as EBT, mean value theorem, and rules, related rates, derivative graph, first derivative test, test for concavity, second derivative test, particle motion, trig natural log derivatives, derivative inverse at a point. This is like a smaller topic that is very specific, and then linear approximation. Okay, and then second semester topics, which is also in this packet, but won't show up until next Thursday. Riemann sums, trapezoid approximation, integration rules like U substitution, long division, or trig, first theorem, second theorem, average value theorem, solving different equations, flow fields, and then finally area volume like this, washer and cross section. Okay. Now, let's go to your formula sheets. Again, you will not get a formula sheet on the test next Monday and Thursday, but I do want to help you focus on what you want to look at for each of the day's tests. So again, in orange, I highlighted pretty much most of the first page. On page 23 are first semester topics, so it can pretty much highlight all that for first semester. The only thing that I put out of order on this first page are your common integration rules. So your common integration rules, those rules are second semester topics, so you're not responsible for those on the multiple choice test Monday. And the trapezoid rule is really Riemann sums and also, I guess, rectangles as well. So those are kind of second semester. But circle, semicircle, triangles, some of these are useful for related rates. Okay, so everything on the first page except for Roman numeral number 9 is second semester. Okay, and then most of second page 24 are second semester material. So first theorem, second theorem, average value theorem, particle motion are all second semester. Area volume, second semester. Volume cross section, second semester. It's just at the bottom of the page. I put I had trouble with the spacing, so I put it in the back here. These are miscellaneous topics. Evaluating derivatives inverse at a point. That's the first semester topic. Log differentiation. That's the first semester topic. Natural log properties, and then second derivative test. Those are first semester topics. Okay, so now right now I ordered your packet with title subsections. So we'll focus on limits of continuity, then we'll do product rule, chain rule, implicit, okay, theorems. On everything is orderly, but on the AP test it'll be mixed. Okay, so I'm not going to put it in the order that you see here, but with the 8 questions, I'll probably space it out between these topics that you see in front of you. Okay, so let's start with number 1. The graph of f is shown above. At what value is the function continuous but not differentiable?
So continuous means connected. Differentiable would mean that it would have to be a smooth curve. So where's the graph continuous but not differentiable? Which point? A, yep. So A is a connected part of the graph, but it's not differentiable. It's not representing a smooth curve. I'm not able to find the slope at that sharp turn. So, okay. Right, and this showed up on the test. Right, there's not a whole lot of work to be shown, so I'm not looking for work if the problem doesn't require it. Right. Okay, number 2. The function is defined above. Which of the following statements is true? Continuous at 2, removable discontinuity, jump discontinuity, discontinuity due to a vertical asymptote. Now, anything with any jump discontinuity, continuity, anytime I see the word continuous, I'm always thinking, and I have a piecewise function, I'm always thinking, okay, let me just step through continuity conditions, because if I step through continuity conditions, I should be able to just, the answer will become apparent because everything is structured within my limit, within my continuity conditions. So we have 3 conditions for continuity. Okay, on page 23, first condition, does the point exist? Does the limit exist? And then finally, the third condition is just looking back at the first 2 and seeing if they are in agreement. Does my limit exist where my point exists? Okay, so the point in question is 2. Right? Very apparent that 2 is the focus of our attention. So let's just go through our conditions here. F of 2. What's F of 2 equal to? 7, right? That second piecewise is giving us that information. Okay, so we keep moving forward. Second condition, does the limit exist? This is a point because of what our piecewise our conditions tell us, but this is the graph. Okay, x doesn't equal to 2 means that this function is connected, or it's showing everywhere on the graph except at 2. But this is not a curve. This is just a random point that lives on the graph. So the graph is the connected part of my graph is within this expression. So if I want to find limit, I find limit for the curve and not for the point, right? Talking about the limit for the expression here. So limit as x approaches 2. All right, first things first, if I want to evaluate a limit algebraically, what do? Okay, plug in that 2, right? So plug in that 2, 2 times 4 is 8. 8 minus 6 is 2. 2 minus 2 is 0. Denominator is also 0. So there's 2 options here. You know that you got to keep going because there's a limit. We could either go through factoring and reducing, or what's the other option that we now have available? L'Hopital's rule. So I'll go through both options so you can kind of see that connection, but obviously you'll get to choose. And most students prefer L'Hopital's rule just because it sometimes can be a little faster. Okay, so if I factor this, multiplies to be -4. If I did A times C. Thank you. Just yeah, thanks. Okay, multiplies to be -4, adds to be -3. That's going to be -4 and 1 with leading coefficient 2 and 2. This reduces to be -2. I keep that 1/2. I get x minus 2, x plus 1/2. Force that 2 out in front, x minus 2 and 2x plus 1. Factoring allows me to, or reducing allows me to rid myself of that 0/0. I reevaluate. 4 plus 1 is 5. So my limit is 5. Okay. The other option, you guys can also do L'Hopital's rule. So take the derivative of the top, 4x minus 3. Take the derivative of the bottom, x minus 2 becomes what? What's x minus 2's derivative? Just 1, okay. And then reevaluate, plug 2 in for x. I get 4 times 2 is 8, 8 minus 3 is 5. So that's your other option. Okay, so I want to make sure that you guys see that connection. If you get 0 over 0, you can either factor and reduce and reevaluate, or like a lot of students prefer Levenfeld's rule, and eventually get to your limit even faster. Okay, so that's the same condition. It passes, it does have a limit, so we keep going. So now the third condition is simply looking back at our first and second condition. Are these in agreement? Are these the same? They're not, right? So we can say that f of 2 does not equal to the limit as x approaches 2 of f of x. So if the curve, so for instance, if the graph at 2 exists at 5, that means where the limit is. But then the point is living in a different place, f of 2 equals 7. Then what can we say? I mean, it's obviously not continuous, so that's out. What type of discontinuity is this? Removal, right? This is a whole discontinuity. Okay. There's a jump discontinuity, the graph will look like this, where it's disconnected branches. Okay, question with 2. All right, number 3. We have a piecewise function here. You have 2 branches, natural log from 0 to 2, and then x squared natural log of 2 on from 2 to 4. And it's asking what's the limit as x approaches 2. Well, I have 2 separate branches here, and I want to find limit as x approaches 2. I really need to rely on one side limit, because I can't just do one limit expression, because I have 2 functions here. But if I find the limit as x approaches 2 from the left and from the right for both of these, I can see if they are actually moving towards the same target. Okay. So we'll do limit as x approaches 2 from the left side of 2, because 0 to 2 is on the left side of 2 of natural log of x. And then separately, I need to find the limit as x approaches 2 from the other side of 2, right? Between 2 to 4, other side of 2 is going to be x squared natural log of 2. Now, don't let that one side limit throw you off, that notation. You're just plugging in the whole the integer value, no decimals, right? We don't do any decimals unless we hit a certain issue. So if I plug 2 in for x, I just get what? Natural log of 2. So that's just whatever that y value is. If I plug 2 into the other expression, what I get here? 2 squared is 4 natural log of 2. Are these the same? They're not, right? So that means maybe the graph at 2 looks like this. One side is headed towards natural log of 2. The other side is headed towards 4 natural log of 2. There's a disconnect. So therefore, the limit, what? Doesn't exist, right? Because in order for them to exist, they must point towards the same y value, and they don't. All right, number 4 looks like a messy limit problem, but we don't know what's going on. So what's the first thing that we should try to do? Plug in, right? Because we don't know, right? Maybe it's already a real number. Maybe it's a whole. Maybe it's the limit doesn't exist because it's a vertical asymptote. We just don't know, right? So the way we can find out information is just by evaluating, right? Let's gather some information here. So pi goes in for all the x's. Okay, what's cosine of pi? -1. Sine of 2 pi is 0. So -1 plus 0 plus 1 is 0. Pi squared minus pi squared is 0. There's a hole in the graph, but the limit exists. We just haven't found it yet. Now, this is not something that we can really factor, or conjugate doesn't work, complex fraction doesn't work. We're kind of forced into using what? Right? So sometimes your some limit problems allows you that that flexibility to choose between options, but this one we clearly have no other option except for L'Hopital's rule, so. Okay, so we're going to find the derivative of the numerator and the denominator separately. What's cosine's derivative? Negative sign. What's sine of 2x's derivative? Sine of u becomes cosine of u times u prime, right? So cosine of 2x times 2. You can put that 2 in front if you like. And then the 1 goes to a 0, okay? Okay, so we're done with the top. We'll deal with the evaluation later. Let's get the denominator cleaned up. X squared becomes 2x. Now, does pi squared become 2 pi? What does that become? 0, right? Pi is a number. It's like 3.14. If I square 3.14, it's like 9 point something. That's still a constant. And constant is still, derivative is still 0. Okay, so now that we have a different version of the expression, now we can calculate what again? Plug in, right? So we should be able to get to a real number. Sometimes you may have a problem that will give you another set of 0 over 0. If that does happen, then you have to L'Hopital's rule again. But we're hoping that this is it, that we can just get it down to a real number here. So let's plug in pi in for x. All right, sine of pi is 0. Cosine of 2 pi is by itself. Cosine of 2 pi is just what? 1. 1 times 2 is 2. 2 divided by 2 pi. Reduce. There's a what left over up top? A 1. So therefore 1 over pi. So this first page, we're able to practice continuity conditions. We're able to see how L'Hopital's rule can play an important role, especially if the other reducing options are not available to us. Now, what if we plugged in our expression and we got like a 10 over 0? It doesn't exist, right? We don't do L'Hopital's rule unless we get this very specific piece of information, right? Because we only do L'Hopital's rule if we realize, oh, there's a hole, the limit exists, I just have to figure out a different way to get to my answer. I gotta do L'Hopital's rule. But if you get a 10 over 0, then your limit doesn't exist. We just stop there. Now, what if I got a 0 over 4? That's 0. That's a real number, right? That's a real number. So I want to just make sure you understand all the different variations of 0 and that, you know, just because you see 0 doesn't mean that it's 0, that they all mean different things depending on where that 0 is located. Okay, next page. Okay, we're still on limits here, but we kind of switched gears a bit when we're dealing with infinity, right? So with infinity, we don't plug any numbers in. We have to really compare degrees here. So what's the degree of the numerator? Yeah, so it's really what square root of 4 means. That's really 2, right? It's really degree 2 here. And denominator is also degree 2. So if the degrees are the same, and if I'm approaching infinity or negative infinity, then my limit is going to be just what? The ratio of the coefficients, right? So square root of 9 is my coefficient, and then 1 is my coefficient below. So the tricky thing here is first understanding this is not really degree 4, it's really degree 2. And second thing is we are going to hold on to that radical. That radical 9 does impact my coefficient. So root 9 for the top, 1 for the bottom. Root 9 is 3. So my limit is 3. Again, oh, I forgot to mention this. It doesn't matter for multiple choice, and also I don't care if it was on my test. But on the AP exam, if this is a free response question, make sure you use arrows for everything. Okay. Don't want to lose the random points. You put equal sign and they're picky about equal signs. Obviously, it doesn't make an impact with multiple choice, and also doesn't impact on my test, just on the AP exam, the response portions. Number 6 feels more complicated because everything is a variable, but treat A as a number. So pretend it was limit as x approaches 3 or limit as x approaches 5, right? So think of A as a number. It's the x that's the variable. Okay, so A is just some unknown number that they haven't shared with us. So what's the first thing we do as we approach a number? Plug in. So we'll replace every x with what? A. Right? So it feels more complicated, but just pretend like that A is just some number. Okay. So A minus A over A cubed minus A cubed. What do we get? 0 over 0. Okay. Now this is factorable, but it's faster if we just went through what? L'Hopital's rule. Yeah. So this gives us the green light to apply L'Hopital's rule. Again, treat A like a number. So let's see what that's going to look like. Okay, what's x's derivative? 1. What's a's derivative? 0. Good. So a is like a 3 or 5 or 6. It's going to go to 0. Okay, x cubed becomes x squared. A cubed becomes 3a squared. Still 0, right? It's a constant. A constant cubed is still a constant. Now that we have a different version of the expression, we can reevaluate. So replace a in for the remaining x. That is something different than a 0 over 0, so we can present that as our answer. Same process, just looks a little bit different because we have that constant a that we have to kind of work around. Okay, moving on from limits, continuity. We're moving on to derivative, second unit material. All right, so if f of x equals x cubed over cube root of x, find f prime. So to find the derivative, we could go through quotient rule, but how can we maybe avoid it? Bring it up, right? Those are compatible, right? If I just it's just one term, and if I just clean up the exponent, I should be able to bring it up and then merge it together. If I can merge together, my hope is that I can just apply power rule instead, right? There's no need to go through a messy rule, especially if these are compatible. So I'm going to spend my time cleaning this up first. Okay. If I want to bring that x up to the top, I'm going to make it into a negative exponent. And if I'm multiplying bases, what do I do with the exponents? So I multiply these two, add them, right? So in this case, add or subtract, depending on what the signs tell us. So 3 minus 1/3 is the same thing as 9/3 minus 1/3. So our function is, this is no calculus yet. All we're doing is cleaning it up so that we can actually get to the derivative portion. Now it's nice and clean. It's the same thing as the original problem, just a lot more easily manageable with our derivative rule. So now we can go through power rule. What's my new exponent? 5/3. And so the answer choices is kind of making it messier than it needs to be, but f prime is equal to 8/3. I can really split this up as x to the 3/3 and x to the 2/3. Right. The reason why I want to bring that up is because, well, it looks like they really want us to separate it based off of what has the x by itself. So if I split this up into 3/3 and 2/3, this is really x to the first power. So it's 8/3 x times x to 2/3 is really cube root of x squared. So that I'm just doing that to help me get to the, let me match my options a little more clearly. So I was down to A and C, but it looks like A is going to be the one that is going to be the better fit. All right, number 8 feels a little okay. So we kind of have to play around with this a little bit here. It says let f and g be differentiable functions. So we know that they're both smooth curves, no sharp turns, no holes. G of x is greater than 0 for all x. So we know that whatever y value that g of x produces is never going to be negative. Okay, so it's always positive. So just keep that in mind. Every value of g graph is positive. Okay, that's what we can gather there. Greater than 0 is positive. Second, f of 0 equals 1. So this tells us that the order pair at 0 is 1. It says that h of x equals f at x times g of x. So we have that as our starting point. It tells us that h prime equals f g prime, which normally it doesn't fit, right? Because if I actually define the derivative of h prime, looking at this, we have to go through what? Not quotient, but product rule. But they're telling us that it's just fg prime. So we know that something is not quite, maybe they were able to reduce it to the point where it's just fg prime. But let's just go ahead and pretend like we don't see this and just build this out so we can kind of see everything in its everything in front of us, and then we can decide how is it that they're able to make h prime just f times g prime. So let's go through a product rule so we can have everything in front of us. Okay, so h prime, if I were to go through product rule here, I get what? Okay. F prime g plus f g prime. Now, h prime here, it's only representing this piece here, right? This piece is gone, completely gone, which means that this must have what? Must have zeroed out, right? It must have zeroed out. So we know that f of 0 is 1. We know that g is always greater than 0. It's always positive. So if it's zeroed out, we know that f prime must be a constant, right? Because if f0, this must be a constant in order for this to zero out, in order for derivative to be just 0, right? So we know that f of x is a constant. And if f of x is a constant, then the only constant that we see here is 1, right? It's got to be 1, right? If it's 0, then this should have been 0 as well, but it has to be 1. That's kind of difficult, kind of looking through some detective work to figure out where the pieces fit. Okay, let's do one more here. Okay, number 9, let f be a differentiable function with f of 2 equals 3 and f prime of 2 equals -5. And let g be a function defined by g equals f of x, which of the following is the equation of the line tangent to the graph of g where x equals 2. So if I want to find tangent line equation, I need to find order pair and slope. So order pair, we're trying to find tangent line equation to g, so we got to do order pair for g of x. So let's find our order pair for g. So I want to find g of 2, because that's the x value in question. So let's just plug in 2 times f of 2. F of 2 equals 3, so 2 times 3 is 6. My order pair is 2, 6. Now to find the slope, I need to find the what? Derivative. To find the derivative, what method is involved here? Product. Good. So we got to do product rule there. So g prime is f prime g plus f g prime. So x is my f of x is my g. So x derivative is 1 times f of x plus x stays. And then what's f of x's derivative? F. It's function notation, so it'll stay as function notation. F becomes what? F prime. So now that we've built our derivative, we can replace every x we see with 2 and see if we can get it down to a number. F of 2 is 3. F prime of 2 is -5. -10 plus 3 is -7. That's our slope. Now, point slope form. That's what we're looking for. Okay, I did pages 1 and 2 with you. Tomorrow I'll check pages 1 through 4. Okay, come get your phones.